Assalamu alaikum wa rahmatullah. Hello everyone. In this video we will be working on question 4 from the coverage of a grade 11 elite for this term, and the question 4 mentioned in the coverage as lesson 2.2. So we have some suggested questions for question 4. The first one is the one you are having right now, which is in front of you, that says the graph of the function f and a table of selected values of f are shown above. The graph of f has a horizontal tangent at x equals 4, and the graph is concave down from 0 to 6 and linear, and it's linear for x is bigger than or equal to 6. So we need to answer those three parts. Part A says approximate the value of f prime of 5. So for part A, f prime of 5.5 will be approximately what? Now be careful here. 5.5 is here on the graph, 5.5 here. Okay, so when you are approximating it, you cannot use f of 6. Yani you cannot say that f of 5.5 lies between 6 and 5. I'm going to use 5 and 6. No, you cannot use this point. You cannot use this point. So you can use f of 5.5 minus f of 5 over 5.5 minus 5. And from the table 5.5, it's 3.244 minus f of 5 will be 3.455 over 5.5 minus 5, and this is equal to what? Negative 0.422, I guess. Negative 0. Let me have a look. Negative 0.422. Okay, so this is the first part. Now, for the second part, it says, is there a value of x for 0 to 6 such that the limit of this amount equals to 0? Well, this limit must look familiar. Okay, this limit, it's the formal definition or the limit definition of the derivative. So this is the same as f prime of x. So for part B, we have to say that this limit of f of x plus h minus f of x over h as h approaches 0, this is the same as f prime of x. Okay, it's the derivative. And the question is saying, is there a value where the derivative equals 0? The derivative equals 0. That means, do we have a horizontal tangent? Do we have a horizontal tangent? Why did we say horizontal tangent? Because the horizontal tangent has a 0 slope. M of the tangent is equal to 0, right? And the slope of the tangent line is the same as the derivative. So the answer should be yes, there is what? There is a horizontal tangent at x equals 4. So it's mentioned here, the horizontal tangent at x equals 4, such that the limit as h approaches 0 of f of x plus h minus f of x all over h equals to 0. It's at x equals 4 because it is a horizontal tangent. So going back to part C here. For each of the following limits, find the value or explain why it does not exist. Before we solve the part C, let's analyze those three limits. What do they mean? Well, the last one looks familiar. The last one, it's equal to f prime of 6, right? It's equal to f prime of 6. Because it's similar to part B, the one we just did. This is the definition of the limit definition of the derivative, but at x equals 6. And for part B, for the second one, it is f prime of 6, but from the left. And the derivative from the left, and this is f prime of 6 from what? From the right. Right? Okay. So f prime of 6 from the right, this is the 6, right? And from the right, you will be looking at what? You will be looking at the slope of this line, because if you make a tangent, it will be the same line. So this point here is 6 and 1, and this point here is what? 8 and 0, right? And the first one, one minute. So this is part C. The limit as h approaches 0 from the right of f of 6 plus h minus f of 6 all over h. It's f prime of 6, but from the right side, which is going to be y2 minus y1. This is 0. Yani y2 minus y1, which is 1 minus 0, over 6 minus 8, which is negative 1 over 2. It's the slope of the line segment, and we selected only 2 points. You can use rise over run, whatever method you would like to use, that's fine. So for part B, not part B, so we are still in part C, but for the second one, the limit as h approaches 0 from the left of f of 6 plus h minus f of 6 all over h. Okay, so here what do you notice? You notice that there is what? There is an open dot, right? There is a hole at 6 when we approach it from the left. Okay, and this means what? It means that, now what if we substitute h equals 0 from the left? Here we will get 0, right? Because we are approaching, we are substituting the 0. And f of 6, it's 1 from the table, right? F of 6, it's 1 from the table. But what is f of 6 plus h when h approaches 0 from the left? Yani if you plug in a number here like 0 from the left as, let's say, negative 0.0001, okay? But when you substitute this number instead of h, You have this number plus 6, right? So it will be 6 plus this number, which will be a value less than 6. A value less than 6, which it's going to be here. So you are substituting what? You are substituting 3 for f of 0 plus, f of 6 plus h will be 3, or approaches 3, approaches 3. So 3 minus 1, which will be 2 over 0, this means what? Does not exist. And if you look at the answer key on AP, they are saying that the numerator approaches 3. Sorry, the numerator approaches 2 as the denominator approaches 0. Let me just read it from there again. It says, here. The numerator approaches 2 as the denominator approaches 0. So this one does not exist. This limit does not exist. And the last one, which is the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h, it's equal to f prime of 6, okay, which does not exist because f has what type of discontinuity at 6? A jump discontinuity at x equals 6. What does that mean if it has a jump? That means f, it's not continuous and not differentiable. That means, so f is not differentiable at x equals 6. Okay, there is another method. You can say that the left-sided derivative doesn't exist at 6. So the derivative at 6 doesn't exist. Or you can say there is a jump discontinuity at 6, so it's not differentiable. Good luck.